Hi everyone, welcome to this week's lesson on distance and time, and then it's going to be followed with some practical examples afterwards, and then some exam papers. So I'm going to try and get through the questions that I have included in these slides, and if I don't get through them, I'll attach them to the chat that you can follow afterwards. Okay, so the first thing that we're looking at there is the formula for speed. So average speed is usually the distance travelled over time taken. So the best way to explain this is do out an example. So Eamon cycled for 8 kilometres. That means that Eamon's distance, that's your distance there, I'm going to put a D. For the first 4 kilometres, his average speed was 12 kilometres per hour. So we're going to put S here for speed. For the second 4 kilometres, that's another distance. His average speed was 20 kilometres per hour. That's speed, we'll call that, distance 1, speed 1, distance 2, speed 2. What was his average speed over the entire journey? So, since we know the average speed for the first 4 kilometres, we can calculate the time taken as follows. So we're going to manipulate the formula here. So average speed equals distance over time. Now, if we wanted to get what time is, we would swap these two here. So time would be distance over speed. So that's what they've done here. So time taken is distance, which is 4 kilometres, over speed, which is 12. So it's distance over speed, and you get 1/3 of an hour. So the reason it's given in hours is because we were given our speed in kilometres per hour, so therefore our time must be in hours as well. So the time taken for the first 4 kilometres is 1/3 of an hour. Now you could write that as well as 0.33 of an hour, so whichever way you want. Since we now know the average speed for the second 4 kilometres, we can calculate the time taken as follows. So the same formula as before, so time is equal to distance over speed. So time in this case is 4 divided by 20, which is our speed too. So D over S, which is 4 over 20, and this time is 1/5 of an hour. So the time taken for the second 4 kilometres is 1/5 of an hour. So therefore the total time taken is going to be 1/3, which is the time we got first, plus 1/5. Now when you put that into the calculator, you will get 8 over 15 hours. The average speed over the entire journey is going to be 8 divided by 8 over 15. And the reason that, so the formula for speed is distance over time. The total distance is 8 because it was 4 kilometres for the first half and 4 kilometres for the second. So that's distance, which is 8 kilometres over the total time which we calculated there, 8 over 15. Put that straight into the calculator and you will get 15 kilometres per hour. Okay, so we're on to distance graphs next. This graph shows the distance travelled by a runner during the first 10 seconds of a race. So time is on the x-axis and it's in seconds, and then distance is on the y-axis and it's in meters. So remember that this is always x and this is y. So what we're being asked there is, what is her average speed over the first 10 seconds of the race? Now for speed, remember speed is distance over time. For the first 10 seconds of the race, she travels 70 meters. So it's going to be speed is equal to 70, which is the distance, divided by 10, which is the time. 70 divided by 10, and that is 7 meters per second for the first part. If we scroll down, there's our answer. So average speed is 7 meters per second. Then it asks us, what is her average speed between the 30 meter mark and the 60 meter mark? So we're going to show you how to do that on the graph. So the 60 meter mark is here and the 30 meter mark is here. We need to calculate the time taken for both of those. So if you follow the black line for 60, follow this and down, and it equivalates to 9.25 seconds. Same thing for the 30, over here and down, and it's 7.25 seconds. So the difference between the distance is going to be 60 minus 30. So it's 60 minus 30, which is 30, divided by the time taken. So remember, the speed is distance over time. So the time taken is going to be the difference between 9.25 and 7.25. So these two times here, and that's 2 seconds. So it's 30 divided by 2, and you're going to get 15 meters per second, which is the answer there. So the key thing is speed is always distance over time. So if you can remember that formula, you'll be able to get most of the questions. Okay, so this is bringing us on to the first practical example. So this is from 2013, paper 1, and it's question 15. Okay, so the graph below shows some details about a journey Alex made by bicycle. So you can see here on the x-axis we have time in minutes, and the speed, on the y-axis is kilometers per hour, so that's speed. Okay, so how long did he wait before setting out? So how long did he wait in minutes before starting his journey? Well, there's no movement between 0 and 5, so that would be 5 minutes there. So it's 5 minutes, and it's really important that you write your correct unit there as well. So he waited 5 minutes before he started his journey, because at 5 on the x-axis, that's when the journey begins. What was Alex's highest speed during the journey? Now, speed is the y-axis, so let's go to the highest point on the graph on the y-axis. It's going to be here, and that comes across to 20. So it's 20 kilometers per hour, because that's the highest point on the graph. So it's 20 kilometers per hour for that one. For what length of time was Alex traveling at his highest speed? So how long was he traveling for 20 kilometers for? Well, he started at 25 minutes and he carried on until he got to 35 minutes. So he stayed at that speed. So 25, the difference between 25 and 35 is 10 minutes for that one. And then how far did Alex travel at the highest speed? So how far? So distance. So remember, speed is distance over time. We are looking for distance. We don't have the distance, but we do have the speed and time. So we need to rearrange the formula here. So I'm going to do this in 2 steps. I'm going to rearrange these two. So time is distance over speed, and I want to get distance on its own. So I'm going to bring this back underneath. So distance is speed by time. Now, how far did Alex travel at the highest speed? So the highest speed we're after getting was 20 kilometers per hour. So that's going to be 20 kilometers per hour multiplied by the time taken to travel that, multiplied by the time taken that he spent at that speed. Now it's really important, we got 10 minutes, but we need to convert that to hours because we're using speed in kilometers per hour. So minutes in hours is going to be 10 minutes in an hour is 10 over 60, because it's 60 minutes in an hour, which is 1 over 6. So 1/6 of an hour. So multiply by 1/6 of an hour, and that will give you your distance. You can put that straight into the calculator and you'll get 3 1/3 kilometers. So 3 1/3 kilometers, or it can be written as 3.33 kilometers. And that's the end of that question. So we're on to 2014 now, paper 1, question 8. Okay, so the students in a PE class are doing a fitness test. Each student runs from the baseline of the gym to the halfway point of the gym and back again. This is called a lap. They run a number of laps in the fitness test. The graph below shows Miriam's distance from the baseline for her first lap. So as you can see again, time is on the x-axis and distance is on the y-axis. Time is in seconds and distance is in meters. So that means that our speed is going to be meters per second. So from the graph, how long did it take Miriam to complete her first lap? Now the first lap would be, sorry, I'm just trying to draw the highlighter here. So all the way up and back down again. So we want to see at what point did it hit the x-axis. So it's at this point here, and that is 14 seconds. So it took 14 seconds to complete the first lap. So that's that first bit done. Then the second question, from the graph, how far is the baseline of the gym from the halfway line of the gym? So the baseline of the gym is here, and halfway is here. So how long is that distance? It's 30 meters. So the answer there is 30 meters. Okay, for her second lap, Miriam increases her average speed to 5 meters per second. On the diagram, continue the graph to show her distance from the baseline over the course of this lap. So she increases her speed to 5 meters per second. Okay, so for this one, we need to calculate the time taken when she increased her speed to 5 meters per second. So the distance is still 30. So time is distance over speed. And we were told that she increased her speed to 5 meters per second. So on her second lap, she's still traveling 30 meters. So the time taken to do that is going to be 30 meters divided by the new speed now, which is 5 meters per second. And the time, then when you put that into the calculator, that is 6 seconds. So it asks us then to show on the diagram, complete the graph to show her distance from the baseline over the course of this lap. So she's still traveling 30 meters, but it takes her 6 seconds. So we're at the 14 mark. Okay, so that was at the 14 mark for her first lap. So it takes her 6 seconds. So 1, 2, 3, 4, 5, 6. So it'll take her 6 seconds to get that to that point, and she's still traveling 30 meters. So 30 meters is up here. So you just get your ruler and you join. Mine isn't completely straight there now, but you get the idea. So it takes her 6 seconds to travel the same distance, or 5 meters, traveling at 5 meters per second, but it takes 6 seconds to do that. Now that's for a half lap. Remember, she needs to come back down again. So it's another 6 seconds on the way back down again. So when you put that into the graph, it should be landing here. That's 6 seconds. 1, 2, 3, 4, 5, 6. So we get our ruler and just join that, obviously a straight line, back down. And that's it, I think, for that question. Yep. So we are on to 2015 paper 1 question 8 now. Grania is taking part in a training session. The graph shows the distance that she travelled during the session. The 4 parts on the graph are labelled A, B, C and D, and you can see them quite clearly there. So again, distance is on the y-axis and time is on the x-axis. So write the letters A, B, C and D into the table to match each description with the correct part of the graph. So first of all, Grania runs for 20 minutes. So go back up to the graph. So we need to find where she's running for 20 minutes. So let's just check here. So it goes from 15, 20, 25, 30, 35. That is 20 minutes. So she's running for 20 minutes between here and here. So that's going to be C. Grania stops for 15 minutes. Okay, well that's going to be obvious. It's going to be part D because it's flatlining. So she stops for 15 minutes there. And if you check on the x-axis, it goes from 35 to 50, which is 15 minutes. So that's going to be D. Grania walks for 10 minutes. That's going to be the bit at the start, because if you look here, she's moving for 10 minutes from 0 to 10. So that is going to be A. And then finally, Grania stops for 5 minutes. That's going to be B. I'll just use a highlighter here. That's B there. She stops for 5 minutes. So that's going to be B. Grania runs 4 kilometers in 20 minutes at a steady pace. Find her speed in kilometers per hour. Okay, so let's just write down distance is equal to 4 kilometers. And then our time is 20 minutes. Now we're going to have to convert this because it asks us in kilometers per hour. So we need to convert 20 minutes into an hour. So 20 minutes in an hour, so it's going to be 20 over 60 because there's 60 minutes in an hour, which is 1/3. So it's 1/3 of an hour. Now what we're asked to get speed, so speed is distance over time. So distance in this case is 4 kilometers divided by 1/3. Put that into the calculator and you'll get 12 kilometers per hour for that one. And that's it for part B, or the whole question. So we're on to 2015 sample paper 1 now. Okay, so Olive cycled to the shop to get some milk for her tea. She cycled along a particular route and then returned home by the same route. The graph below shows the different stages of her journey. So you can see on the y-axis, we have the distance from home along the route in kilometers, and then the time is in minutes. So just you need to be aware that they're different units. So usually with kilometers we have hours, and usually with minutes we have meters. Or sorry, we usually have seconds instead of minutes with meters. So we might have to do a conversion here. So first of all, how long did Olive spend cycling for part A? So how long did she spend cycling? Well, she started at this point where time was at 0 minutes, and she stopped at this point. So she spent between the 1st minute and the 10th minute in the cycling. Then she spent this amount of time in the shop, which we're not asked for. And then she spent between here and here cycling home. So that was 5 minutes. So the first 10 minutes between here and here. Sorry, I'm going to come down. So that was actually between 0 and 20. That's 20 minutes for the first part of the journey. She stayed in the shop then. And then on her way home, she spent 5 minutes. So it's going to be 25 in total. 25 minutes. Then it asks, how far is her home from the shop? So how far is her home from the shop? Well, the first part of the journey, if you look at the graph, she starts at this point here and she arrives at the shop at this point here. So if we look at the graph, that is 5 kilometers. So it's 5 kilometers from her home for that answer. Okay, compare the speed of her trip to the shop with the speed of her way on her way home. So I'm just looking at this now. This was actually 10 minutes. That distance is 10 minutes. And then on the way over, it was 20 minutes. So that distance there is 20. So I'm just going to change the first answer. So instead of 25, it should be 30 for that one. Now, go back to this question for a minute. So compare the speed of her trip to the shop with the speed on the way home. Well, let's look at the time first. So the time taken for the route to the shop was 20 minutes. And then the time taken for the route home was 10 minutes. So what that means is that Olive's speed is twice as fast when she was returning home. So Olive's speed was twice as fast returning home as it was going to the shop. Okay, that's that one. Write a paragraph to describe her journey. Okay, so you need to use your proper language here, things like distance, speed, time, kilometers, minutes. What's basically what's in the graph. So let's look at the first part of the journey. So we know that Olive cycled to the shop. It took her 20 minutes to cycle 5 kilometers, which is what we figured out in the first part. So let's start with that first bullet point. So Olive cycled to the shop so actually changed. Olive cycled 5 kilometers to the shop at a time of 20 minutes. Okay, let's look at the next part of the graph, which we actually didn't look at this bit. So how long does she stay in the shop? That's how long she stays in the shop there. Okay, so she stays in the shop between 20 and 35. So 20 and 35, so that's 15 minutes. That's the second bullet point. So she stays there for 15 minutes. And then the last bullet point, she then cycles home. So she then cycles home, which is going to be 5 kilometers in 10 minutes. Now, if we want to just write down another bullet point, how long did the total trip take her? So the total trip took, so the first part of the journey was 20 minutes, which you figured out. Then she stayed in the shop for 15 minutes, and then it only took her 10 minutes on the way home. So 20 plus 15 plus 10 is 45 minutes. Now that's more than enough information there. And a paragraph usually I kind of split into 2 or 3 or even 4 bullet points to separate it out. Okay, so we're on to 2015 sample paper 1, question 9. Tina is standing beside a racetrack. A red car and a blue car are travelling in the same direction at steady speeds on the track. At a particular time, the red car has gone 70 metres beyond Tina and its speed is 20 metres per second. At the same instance, the blue car has gone 20 metres beyond Tina and its speed is 30 metres per second. Okay, complete the table below to show the distance between the red car and Tina and the blue car and Tina during the next 9 seconds. Okay, well, it's travelling at a speed at 20 metres per second. So at a particular time, the red car has gone 70 metres beyond Tina. Its speed is 20 metres per second. So every second it travels 20 metres. So we're going to go up in 20. So it goes from 70 to 90 to 110. Add 20 is going to be 130. 150, 170, 190, 210, 230, and 250. Then for the blue car, so what did it say about the blue car? At the same instant, the blue car has gone 20 metres beyond Tina and its speed is 30 metres per second. Okay, so this one is going up in 30s. So it's 20, 50. So 50 plus 30 is 80. 80 plus 30 is 110. 110 plus 30 is 140. Add 30 is 170. 200, 230, 260, and 290, because that's going as 30 meters per second. Okay. After how many seconds will both cars be the same distance from Tina? So at what point is the distance the same? If you look at the table that we've done, they're both the same when it has been traveling for 5 seconds, so they're both 170. So that's the answer there. So after how many seconds will both cars be the same distance from Tina? It's after 5 seconds. And I'm getting 5 from here because that's the same value for both of them. Okay. After 8 seconds, which car is furthest away from Tina and how far ahead of the other car is it? So after 8 seconds, this is the one we're looking at. Which car is furthest away from Tina? Well, it's going to be the blue car because it's the higher value here, so 260. So the answer there is the blue car. So the furthest from Tina is the blue car. And then it's also asking, how far ahead of the other car is it? Well, what's the difference between 230 and 260? It's 30, so it's 30 meters for that one. For part D, on the diagram, on the next page, draw graphs of the distance between the red car and Tina and the distance between the blue car and Tina over the 9 seconds. I don't think I have that. Oh, I do have it pasted in. Okay. So we have to draw graphs of the distance between the blue car and Tina and also the red car and Tina over the 9 seconds. Okay, so it starts, if we go back up here, the red car starts at time 0, but it's at a distance of 70. So that's where we're starting. So time of 0, a time of 0 and a distance of 70, which they've actually put in red car there. So we just go up in 20s every second. So we're going to go from 70 to 90, which will be here. And then it goes from 90 to 110, which is here. And then it goes from 110 to 130, which is going to be here. 130 to 150, which is here. 150 to 170, which is here. 170 to 190, which is here. I think that's all we had to do for that one. Let me just double check. Oh no, we went right up for the red. Okay, so we're going to keep going up as far as 250. Okay, so we're at 190, we're at 210 next. So 210, 230, and 250, which is here. So that's the red car. So you just get your line, you get your ruler, should I say, and you join up the best fit line. Mine isn't accurate now because I'm not using a ruler, but that's basically it. And then the blue car. So let's go back up. The blue car is at a distance of 20 meters when the time is 0. So we're going to go back down to the graph. 20 meters when the time is 0, so that's going to be here. And remember, it's going up in 30s this time. So it's going from 20 to 50 for the first second, which is here. 50 plus 30 is 80. So 80 is here for part 2, or 2 seconds. 80 and 30 then is 110. So 110 for 3 is going to be there. 110 and 30 is 140 for 4, which is here. And then we have 140 plus 30 is 170, which is here for 4. They're intersecting at that point. Then 170 and 30 is 200 for part 6. So it's going to be here, or time of 6. 200 plus 30 is 230. So 230 for 7 is going to be here. And then finally, 230 plus 30 is 260 for 8, which is up here. And you get your ruler and you draw the best fit line for that as well. That's it there. Okay, write down a formula to represent the distance between the red car and Tina for any given time and state clearly the meaning of any letters that you used in your formula. Okay, so we're looking at the red car. What's happening with the red car? So the red car starts at a distance of 70 meters from Tina. Okay, so the red car starts off at a distance of 70 meters from Tina and increases, so it goes up by 20 meters per second, or 20 meters, sorry, every second. So a formula for the distance would be 70, because you're starting at a distance of 70, plus 20t, where t is time in seconds. And then finally, write down a formula to represent the distance between the blue car and Tina for any given time. So remember, for the blue car, so the blue car starts off at a distance of 20 meters from Tina. See here, 20 meters, that was for the blue car. And then it increases by 30 meters every second. So for that reason, distance is going to be your starting, so it's 20 plus 30t, where t is time in seconds. So that's it, that's that question done. That's all I have time for today. I'm going to attach the extra questions I didn't get done into the chat, so I'd recommend that you follow them. And I'll also add in some extra video tutorials or links to the extra video tutorials on the Maths Tutor website. And I'll speak to you soon.